Another principle that we're going to use with polarity and molecule shapes and size and how big they are, all that, is this idea of how to separate them. So if you've all seen tie-dye t-shirts before, if you've ever made a tie-dye t-shirts, they're kind of fun. I recommend you do it over the summer. But you put a piece of dye right here and it'll spread out and it'll have these characteristic colors that are going to come out, and it's going to spread out all the colors of the dye. And so what chromatography is, you can think of chromo meaning color. Chromatography is that you have yourself your container of your liquid right here, and then you're going to put into it like paper, cellulose, or a silica gel, or you're gonna have whatever, but you're gonna have this paper right here, and could be wet with water. It doesn't have to be wet. It's what's called a stationary phase. This is the mobile phase. But what's gonna happen is there's a process called capillary action where the liquids are gonna grab onto each other, and grab hold of the paper towel and kind of crawl their way up. So they're gonna kind of keep moving their way up the paper towel. Now, it should make sense to you a couple things. What's going to happen is over time, the components in here will begin to spread out and travel up this paper towel, and they'll move up the paper towel to different heights. And so you have this fluid down here, and let's just say this fluid is black ink. All right, and so what ends up happening is over time, it's gonna separate. These guys are gonna crawl up the paper towel. Now, why does it separate? Why does it separate into different colors? Well, it should make sense. If you are very polar, then you're holding on to each other down here, and you're gonna be tied in at the bottom, much less likely to move up. So imagine if you got a big group of friends. Y'all are hanging out, y'all are having fun, and y'all are at a party, and when you're at this giant, huge party, and when you're at this party, if you're really, really having a good time, you have this real big group that's super fun, everything's going great, the less likely is you're gonna get up to go find other things to go do. But if you show up to a party, y'all are having an okay time, it's not a hootenanny, what ends up happening is you get up and you're like, oh, let's go mingle. I have less things holding me here. So what happens is down here, the most IMFs stay at the bottom, and then the least IMFs move up. So that's one way it separates. Another way it separates is just simply by weight. The heavier objects will stay at the bottom, the lighter objects will move up because it's got to overcome gravity. And so you can fight this by not having it laying upwards, you can have it laying sideways, but then even then, larger molecules tend to have more intermolecular forces. The larger the molecule, the more surface area. So this has attraction between where our fingers touch, but then this is gonna have more attraction, this is gonna have more attraction. So the larger the molecules, typically the bigger the intermolecular forces. Paraffin wax, once again, C25H52, giant long, it's a solid at room temperature. Methane, gas at room temperature. Then we start moving up, and octane is a liquid at room temperature. That's gasoline. And so you start seeing the bigger the molecule, typically, it's also the more IMFs. So that's chromatography. There's just a simple little thing. It's just a little lab technique to separate mixtures out. Outside of that, that should be it for when it comes to making solutions, or when it comes to like how liquids interact and behave. This is just a small little idea.